Now, let us start our new chapter, the calculating sample size and power. Calculating sample size and power. First question. Statistical power is defined as the probability of A. Accepting a null hypothesis when it is false. B. Rejecting a null hypothesis when it is true. C. Rejecting a null hypothesis when it is false. And D. Failing to reject a null hypothesis when it is false. So the statistical power is defined as the probability of what? So among the options they gave, this answer number C, option number C is correct. That is, rejecting a null hypothesis when it is false is the option. See over here. What is beta? Beta is the probability of failing to reject the null hypothesis when it is false. Okay, or the probability of making a type 2 error. But what is power? The probability of correctly rejecting the null hypothesis when it is false. So it is commonly denoted by 1 minus beta. So therefore, the answer for this question is rejecting a null hypothesis when it is false is the answer for the statistical power. Next question. Steps in the estimation of sample size included all of the following except steps in the estimation of sample size. Okay, so the options given are A. Identify the major study variable. B. Decide on the desired precision of the estimate. C. Adjust for population size. Or D. Adjust for selection bias. The answer for this question is D. Adjusting for selection bias is not a step in the estimation of the sample size. So let us see the other steps. Identifying the major study variables, yes, it is present. Decide on the desired precision for the estimate, yes, it is correct. And adjust for the population size, it is correct. See over here, they have advised identifying the major variable, yes, this was there. Determine the type of estimate, yes, this was there. Population size was there, yes, this was there. But the adjustment for selection bias was not mentioned here. Okay, now next question. A type 2 error occurs when the options they gave are A. The null hypothesis is rejected when it is false. B. The null hypothesis is not rejected when it is false. C. The null hypothesis is not rejected when it is true. Or D. The null hypothesis is rejected when it is true. So the answer for this question is the null hypothesis is not rejected when it is false. Let us see how the answer became the null hypothesis is not rejected when it is false. To know this, first of all, you have to know what is type 1 error, what is type 2 error, what is hypothesis. See, basically, hypotheses are of two types. One is the null hypothesis and the other one is alternative hypothesis. Both of them are opposite to each other. Both of them are opposite to each other. Now, when you do testing, then you will come to conclusions and then few errors will also come. This is type 1 error and this is type 2 error. You please remember this chart or this small mnemonic type of table what I prepared. Okay, so it will be easy for you in the exam. Whenever such question comes, you just blindly put this table and then you will come to the answer. This type 1 is also called as alpha. Type 1 error is also called as alpha error. Type 1 error. Okay, errors. Type 2 is beta. Okay, now first you have to think what is positive and negative. In type 1, what will be there? There will be false positive. You please remember this, false positive. Okay, in type 2, what will be there? In type 2, what will be there? You will be having false negative. See how I have made false negative. Okay, in type 1, false positive. In type 2, false negative. Okay, then you have to whether it is acceptable, accepted or rejected Okay, so here you have to, in type 1, what will happen? It will be true rejection, whereas in type 2 it is falsely accepted. It is truly rejected. This is truly rejected. So whenever such question, type 1 error or type 2 error, whenever they come in the examination, simply put this table. Try to by heart how to put a table. You first write errors like type 1 and type 2, what are they? They are alpha and beta. Then positives and negatives, what are they? In type 1, invariably you will have false positive. Okay, false positive. Then in type 2, it will be false negative. Then whether it is accepted or rejected, over here in the type 1 side, it is truly rejected, whereas type 2 is falsely accepted. This is the only table you have to remember in the examination. So our question said a type 2 error occurs when what? Our answer was that the null hypothesis is not rejected when it is false. The null hypothesis is not rejected when it is false. False is false. Okay, not rejected in the sense accepted. When it is accepted, that means it is not rejected. Okay, so therefore this is the answer for this question. The null hypothesis is not rejected when it is false. Let us see the other options. The null hypothesis is rejected when it is false. There is nothing like rejected when it is false. Either it should be rejected when it is true. Okay, so then the C option, the null hypothesis is not rejected when it is true. If it is not rejected, it should be accepted. So if it is not rejected when it should be false, not true. So this statement itself is wrong. This statement is also wrong. Now coming to the last statement, the null hypothesis is rejected when it is true. Rejected when it is true. If it is rejected and it is true, it comes into type 1 error. Okay, so for this question, a type 2 error occurs when the null hypothesis is not rejected when it is false is the right answer. Next question. Exact calculation of design effect for the study parameter can take place after the study completion. Is it a true statement or a false statement? Exact calculation of design effect for a study parameter can take place after the study completion. Is it a true statement or a false statement? Now the answer is that it is a true statement. Please remember this point. It can take place after the study completion also. Next question. Population variance can be estimated from what? The options they gave are A. Pilot study, B. Reports of previous studies, or C. Only by guessing, or otherwise D. That is both pilot study and reports of previous studies. So from the options given over here, the answer, the option number D, that is both A and B are correct. That is a pilot study is also correct, and the reports from previous studies also is a correct option. So therefore population variance can be estimated from a pilot study and from the reports of previous studies. Now we look at the next question. The recommended minimum level of power for an analytical study is what? The options they gave are A. 5%, B. 95%, C. 80%, or D. 0.05%. So the recommended minimum level of power for an analytical study is C. 80% is required minimum. Okay, then next question. In general, the sample size formula takes into account the crude association between exposure and outcome as well as confounders. So is this statement a true statement or a false statement? In general, the sample size formula, the formula will take into account the crude association between exposure and outcome and as well as the confounders. So is this a true statement and a false statement? Definitely it is a false statement. Sorry, it is a false statement. So the answer for this question is that it is false. Okay, it will not take into account. Next question. Design effect of more than one needs to be considered in studies involving what? The options they gave are A. Cluster sampling, B. Simple random sampling, C. Stratified random sampling, or D. Non-profitable sampling. Once again, the design effect of more than one needs to be considered in studies involving what? So the answer for this question is cluster sampling. How? The desired effect can be calculated after study completion. Okay, this was one question. After study completion was one question. Okay, but should be accounted for at the design stage itself. Okay, so the design effect is 1. If the design effect is 1, that is when you have no design effect actually. So when you are taking a simple random sampling into consideration. then the design effect varies using cluster sampling. It is usually estimated that the design effect is 2 in immunization cluster surveys. So our question was that if the design effect is more than 1, okay, so see over here, it is more than 1, it is 2. So it comes under the cluster sampling. So the answer for this question, cluster sampling, is correct. But if the design effect would have been given as 1, then it is simple random sampling. The simple random sampling is design effect will be is equal to 1. Okay, you please remember this point. Now we'll go to the next question. Which of the following is necessary in sample size determination? The options are A, the desired confidence level, B, desired precision, C, magnitude of the population variance, or D, all of the above. So what are all required? So let us see the options again. For sample size determination, desired confidence level, yes, this is necessary. Desired precision, yes, even this is necessary. The magnitude of population variance is there, yes, even this is necessary. So ultimately all of the above are necessary. So the answer for this question is D, all of the above. C, decide on the desired precision is given in the option. Population size is given in the option. Now coming to the next question, which one of the following statements is false? Design effect is a relative change in the variance due to use of clusters. Or option B, as the magnitude of the expected effect increases, the required sample size increases. Or option number C, the population variance is unknown in general and has to be estimated. Or option number D, larger the sample size, smaller will be the sampling error. So which of the following statements is false statement? So let us see each and every statement again. The design effect is a relative change in the variance due to the use of clusters. Yes, this is a true statement. Second statement, as the magnitude of expected effect increases, the required sample size increases. No, this is not a correct statement. Third one, the population variance is unknown in general and has to be estimated. Yes, even this is correct. Then lastly, larger the sample size, smaller will be the sampling error. Yes, even this is a correct statement. So we got the answer over here. Next question, a type 1 error occurs when the options they gave are A, the null hypothesis is rejected when it is false, B, the null hypothesis is not rejected when it is false, C, the null hypothesis is not rejected when it is true, or D, the null hypothesis is rejected when it is true. So the answer for this question is D, the null hypothesis is rejected when it is true. So true rejection. Now see how do we come to the answer. Whenever this question arrives, like a type 1 error or a type 2 error, I told you that you should put a table. You write down type 1 error and this is type 2 error. Type 2 error. You will be given a pen or a pencil and a paper in the examination for rough notes. So you have to put the table in this manner. Okay, then write positivities and negativities. How will you write? This is 1. So in type 1 error is also called as alpha. Type 2 is also called as beta. So this is 1, you write as 1, and this is 2, you write as 2. So how will you convert it? You convert it into positive. You convert this type 2 into negative. What are they? Both of them are false positives and false negatives. Then next, accepted or rejected. Accepted or rejected. Okay. How will you put it in the table? This was false positive. So it was rejected. Truly rejected. This is false negative. So because this is truly rejected, then this will be falsely accepted. This is the only table what you have supposed to put or supposed to by heart to answer this type of question where they ask for regarding type 1 error and type 2 error. Because ours is only a basic course, that is examination for BCBR, basic course in biomedical research. Our subject or our idea pertaining to this table should be sufficient to answer this question. Now coming to the answer for this question, a type 1 error occurs 1. Let us see the options. Option A, they gave that the null hypothesis is rejected when it is false. Is it possible? Rejected when it is false. Rejected when it is false is wrong. So this is not the answer. The null hypothesis is not rejected when it is false. Not rejected when it is false is what? Not rejected implies it is accepted. Not rejected means it is accepted. When if it is accepted when it is false is this one, this box. So this should be a type 2 error, not a type 1 error. So even this is not the answer for this question. Third one, the null hypothesis is not rejected when it is true. Not rejected when it is true. When it is true, there is nothing like not rejected. Here it is was rejected. So even this is a wrong statement. Now let us come to the fourth statement. The null hypothesis is rejected when it is true. It is rejected when it is true. So this comes for type 1 error. Type 1 error. So this is the answer for this question. So this is how you have to answer this type 1 error and type 2 error questions. Let us see the next question. Which of the following is true about beta error? The options they gave are A. It is the probability of correctly rejecting the null hypothesis when it is false. Or B. It is the probability of accepting the null hypothesis when it is false. Or C. It is the probability of rejecting the null hypothesis when it is true. Or D. It is the probability of making a type 1 error. So, what is the answer for this question? The answer is B. That it is the probability of accepting the null hypothesis when it is false. Let us see the next question. All the following are essential statistical considerations for sample size calculation. Okay, essential statistical considerations. Except what? The options they gave are A. Desired precision, B. Anticipated proportion of factor of interest, C. Sampling method, or D. Allocated budget. So out of these four available options, the answer is that the allocated budget. Allocated budget is not considered for sample size calculation. Rest of the things, now let us see. Let us see the desired precision. Is it available or is it present in the list over here? Yes, it is there. See, the desired precision is there. Next, anticipated proportion of factor of interest is there. Yes, even this has been mentioned. Sampling method is there. Yes, sampling method in the sense the design effect. I told you, if the design effect is equal to 1, then it is simple random sampling. If it is more than 1, then it goes into cluster sampling. So that was a discussion what we have made a few questions back. Then last one, the allocated budget option is given. No, it is not available in the steps in estimating the sample size. Okay, so this will be the answer for this question. Let us see the next question. For each confounder or variable added into the study, empirically, 10% increase in the sample size should be made. Is it true or false? Once again, for each confounder or variable added in the study, empirically, 10% increase in the sample size should be made. Is it true or false? Yes, it is a true statement. Okay. Now the next question. The design effect should be calculated after completion of the study and it need not be counted at the design stage. Is it a true statement or a false statement? The answer is that it is a false statement because the design effect should be calculated after completion. Yes, this is the correct part, and need not be counted at the design stage. Need not be is not. It can be counted at the design stage also. Next question. When estimating the sample size for a cross-sectional study, we need to account for the following options are there. A. Expected proportion of characteristic of interest. B. Estimated design effect in case of cluster sampling. Or C. Population size, or all of the above. The answer for this is that it is all of the above. So when estimating the sample size for a cross-sectional study, okay, for a cross-sectional study, we should account for the expected proportion of characteristic of interest, estimated design effect in case of cluster sampling. I told you, design effect if it is more than 1 in case of cluster sampling. If it is equivalent to 1, then it is simple random sampling. Simple random sampling. Okay, then population size and all of the above. So answer is all of the above. Let us see the next question. The power of a study is what? The options they gave are does not influence the sample size, B represented as alpha, C can be defined as a probability of correctly rejecting the null hypothesis when it is false, or D, represented as the probability of making a type 1 error? So it is a very simple answer. It is option number C, that is, it can be defined as the probability of correctly rejecting the null hypothesis when it is false. Let us see the next question. The following are needed to calculate the sample size for analytical studies using simple random sampling method, except the options they gave are: A, desired value for the probability of alpha; B, magnitude of the expected effect based on previous studies; C, desired value for the probability of beta; or D, estimated design effect. The answer is very simple. You don't require an estimated design effect whenever you are using simple random sampling method. See over here. The design effect can be calculated after study completion. This is one question, okay, for the design effect, but should be accounted for at the design stage also. So this is also one more question for the design effect. And one more question, the design effect is 1, or if there is no design effect when you are taking a simple random sample into consideration. Okay, so when simple random sampling is used, you don't require an estimated design effect. So this is the answer for this question, but we will continue the design effect discussion. If the design effect is more than 2 or more than 1, it can be used in cluster sampling. Okay, then next question. A researcher wants to estimate the prevalence of surgical site infection following cesarean section at the tertiary care hospital. What would be the minimum number of sample size? They have asked us to calculate the minimum number of sample size to estimate the magnitude of surgical site infection following cesarean section. If it is estimated that the proportion of surgical site infection will be 10% in the hospital, considering 5% absolute precision and 95% confidence levels. So the options they gave are, or the answers they gave are: A, 100, B, 138, C, 148, or D, 158. The answer for this question is, after calculation, B, 138. Now how do we solve such type of question? Let us see how do we solve. Once again we will read out the question. A researcher wants to estimate the prevalence of surgical site infection following a cesarean section at a tertiary care hospital. So what would be the minimum number of sample size to estimate the magnitude of surgical site infection following a cesarean section if it is estimated that a proportion of surgical site infection will be 10% in the hospital, considering 5% absolute precision and 95% confidence level. So what they have asked was, they have asked the minimum number of sample size, and they have given, if it is estimated the proportion, they have given proportions. So what is the formula for calculating the minimum number of sample size? Is given by n is equal to, for the proportions it is given as n is equal to z square into p q, that is p into q, divided by d square. Now what is z? Z is nothing but the 95% confidence level. So it is given, they themselves gave the valuation as 1.96. So n is equal to 1.96 into 1.96. So the value of z is 1.96. Okay, into what is p? What is p? P is nothing but what? P is nothing but prevalence. The prevalence is given. How much is the prevalence? 10%. So 10%. So how much will be 10%? Prevalence is 10%. So you write 10. Okay, into q. What is q? Q is given by the formula q is equal to 100 minus p. So q is equal to 100 minus 10, which will be 90. Okay, so this is 90. Okay, so here the numerator part is over. Now coming to the denominator part, d square. What is d? D is the absolute precision. So how much is the percentage they gave? It gave 5%. So you directly take 5 as the value. So it is 5 into 5 because it is 5 square. This is the formula. Okay. Now once if you calculate, okay, So this is 5 ones are 5, 5 twos are 10. Okay, 5 ones are 5, the 5, 5 eights are 40. So 1.96 into 1.96 into 2 into 18. 1.96 into 1.96 into 2 into 18 is equal to 138.2, is equal to 138.2. So this is the answer for this question. That is, the minimum number of sample size will be 138.2. So this is how you have to solve this question. Let us see the next question. Precision is described as a measure of how close an estimate is to the true value of a population parameter. Is this a true statement or a false statement? This is a true statement. Precision is described as a measure of how close an estimate is to the true value of a population parameter. This you have to remember. This is the definition of precision. Next. In a cross-sectional study, a group of researchers wanted to estimate the prevalence of cephalosporin-resistant E. coli among the adult males with the UTI. Then from previous literature, the prevalence was found to be 6.5%. If the researchers want to estimate the prevalence with a 20% relative precision and 95% significance level, then what is the minimum sample size requirement? So the options they gave are A 1042, B 1381, C 6 or D 600. So among the options given, the answer is B 1381. Now let us see how can we solve this question. In a cross-sectional study, group of researchers wanted to estimate the prevalence of cephalosporin-resistant E. coli among adult males with the UTI. So from the previous literature, the prevalence was found to be 6.5%. Okay, so they gave the prevalence 6.5% is one value what we got. If the researchers want to estimate the prevalence with a 20% relative precision, 20% relative precision. See, this is not absolute precision, this is relative precision. Okay, now what does that mean? 20% relative precision. 20% relative precision means the D value you have to take it as 20% of prevalence, that is 6.5% you have to take. Okay, so if you solve this, it will come to around 1.3. This will come to around 1.3 if it is relative precision. But if it would have been an absolute precision, then the D value would be directly 20. Okay, now another variable what they gave, we got P, we got D, and this is 95% significance level. Okay, so the level of confidence will be how much? Level of confidence is Z value. The Z value, when they are giving 95% of significance, then it will be standard 1.96. 1.96 is there. So now you have Z, you have P, you have D, and what is left out? You want Q value. What is Q? Q is equal to 100 minus P. So it is 100 minus 6.5. So 100 minus 6.5 is how much? It will be 93.5. Okay, now what is our formula? So we are also got Q value. Okay, now Q value is over. So what is our formula? What is our formula? What is the minimum sample size required? N. N is equal to Z square into PQ by D square. Now substitute all the values. What is Z square? 1.96 into 1.96 into what is P? P is nothing but 6.5. Okay, 6.5 P. What is Q? Q is nothing but 93.5. 93.5 by D square 1.3 into 1.3. If you solve this whole thing, it will come to 1381.4. Where is this value? It is over here, B. Okay, so this value is matching over here. So this is how you have to solve this question. Most important is the formula is important. Okay, and you have to identify the P value, you have to identify D value, you have to identify Z and Q. Coming to the next question, which of the following factors is not essential for calculating the sample size for a single mean estimation? So the options they gave are A. Need for statistical significance, B. Assumptions about the population standard deviation, C is precision, or D is significance level. So what is not required? The answer for this is A. Need for statistical significance. Whenever you are calculating the sample size for a mean estimation, you don't require any statistical significance. Okay. Then next question. Adjustments to a calculated sample size need not be done for which of the following reasons? Options are A. Non-response rate, B. Finite population size, C. Cluster design, or D. Hospital based study. So adjustment for a calculated sample size need not be done for which of the following reasons? The options we told were non-response rate, finite population size, cluster design, or hospital based study. The answer for this is hospital based study. For a hospital based study, adjustments to a calculated sample size need not be done. Next question, state whether true or false. A pilot study can be conducted to get an estimate of expected prevalence of the disease being studied to calculate the minimum required sample size. Is this a true statement or a false statement? Once again, a pilot study can be conducted to get an estimate of expected prevalence of a disease being studied to calculate the minimum required sample size. Is it true or false? It is a true statement. Next question. A cross-sectional study aims to estimate the prevalence of high-death liver disease among patients undergoing ultrasonography in a tertiary care hospital. So which of the following is not required for calculating the minimum required sample size for this objective? So the options they gave are A. Significance level, B. Assumed prevalence, C. Precision, or D. Population variance. The answer for this question is D. Population variance. Population variance is not required. Once again, the cross-sectional study was aiming to estimate the prevalence of high-death liver disease among patients undergoing USG in a tertiary care hospital. When you are taking tertiary care hospital, so you will want a significance level, assumed prevalence, precision, but not a population variance. Next question, what is type 1 error? The options they gave are A. The probability of accepting the null hypothesis when it is false. B. The probability of rejecting the null hypothesis when it is true. C. The probability of rejecting the null hypothesis when it is false. Or D. The probability of accepting the null hypothesis when it is true. So what is the answer? Type 1 error is nothing but option number B. The probability of rejecting the null hypothesis when it is true, TR. Let us see how the answer came for this question. As I told, we will quickly put the table. Type 1 error, type 2 error. Type 1 is also called as alpha, type 2 is also called as beta. 1, 2. Now make this 1 into P, make this 2 into N. Okay, so this is false negative, this is false positive. Because it is false positive, you are rejecting it, it is truly rejected, and because here it is truly rejected, it will be falsely accepted. This is the table. Whenever this question comes, you have to put in your brains, or otherwise you have to put on the rough paper given to you in the examination. So let us see the options. Type 1 error, number A, the option number A, the probability of accepting the null hypothesis when it is false. So when it is false, the probability of accepting the null hypothesis, if this is there, then it should have been type 2 error. So it should have been type 2 error. So this is not the answer for this question. Then second option, the probability of rejecting the null hypothesis when it is true. The probability of rejecting the null hypothesis when it is true. Yes, when it is true. So this is the answer for this question. Now let us see the other two options. The probability of rejecting the null hypothesis when it is false. The probability of rejecting the null hypothesis when it is false. but here it is true. So this statement itself is wrong. It is not possible. And then the last statement, the probability of accepting the null hypothesis when is true. The probability of accepting the null hypothesis over here when it is true is also not possible. So the answer for this question is this one, that is the probability of rejecting the null hypothesis when it is true is a type 1 error, or it is seen in type 1 error. Next question. The ability of a study to detect correctly the presence of an association is known as what? The options they gave are A. Precision, B. Power, C. Confidence, or D. Significance. What is it? The ability of a study to detect correctly the presence of an association is known as power. Next question. Now next question. The standard deviation of a sampling distribution is called a systematic error. Is it a true statement or a false statement? The answer is that it is a false statement. The standard deviation of a sampling distribution is not a systematic error. Okay. Now next question. Design effect is considered for which of the following sampling strategy? The options are A. Cluster sampling, B. Simple random sampling, C. Stratified random sampling, or D. Non-probability sampling. The answer is very simple. The design effect will be considered for cluster sampling, because design effect, if it is 1 or no design effect, then it is for the simple random sampling. But for if the design effect is more than 1, then it is used for cluster sampling. Okay, cluster sampling. Next question. In a hospital-based cross-sectional study, it is planned to estimate the mean D-dimer levels among the COVID-19 patients. So from the previous literature, the standard deviation was found to be 200 nanogram per ml. If the researchers want to estimate the mean with a 15 nanogram per ml precision and 95% significance level, then what is the minimum sample size requirement? So the options they gave are A 62, B A 62, B 16, C 31, or D 248. The answer for this question is A 62. Let us see how do we solve this question. See, what is the question they have asked? What is the minimum sample size required? Sample size required in the to estimate mean. Okay, so here the formula will be sample size is equal to z square into the square of standard deviation by d square. Please remember that this formula is different from the formula which has been used to calculate the minimum sample size for the proportions. In the proportions, the formula was like a sample size formula was n is equal to z square into p by q by d square when proportions were being taken into consideration. But once standard deviation and mean are given, and you are calculating once standard deviation is given and you are asked to estimate the mean, then what will be the sample size? You have to use this formula. Okay, so what are the other variables they gave? Let us see. They gave the standard deviation was found to be 200. Standard deviation, yes, this is equal to 200. Okay, and 50 nanogram per ml is the precision. So D is equal to 50. Okay, D is equal to 50. Then 95% of significance level, that is Z, level of confidence is equal to 95% of the significance level, which is 1.96. So once you substitute n is equal to 1.96 into 1.96 into 200 into 200 divided by 50 into 50. Okay, it's so 1.96 into 1.96 into 16. This will come to 61.4. So the answer is 62. So this is how you have to calculate. Please remember that when once standard deviation is given, and if the researchers want to estimate the mean and they are asking the sample size, then you have to use this formula. But if they give proportions, then you have to use this formula. You cannot use this formula whenever standard deviation is being given, because there will not be any chance for substitution. Where will you substitute the standard deviation value? Okay, so this is how you have to solve this question. Let us see the next question. The probability that an estimate of an population parameter is within certain specified limits of the time value is known as what? The options they gave are A, power, B, confidence level, C, sample size, or D, precision. The answer for this is B, confidence level. Whereas precision is the measure of how close an estimate is to the true value of a population parameter. Okay, so this definition is different. The answer for this question, that is the probability that an estimate of a population parameter is within the certain specified limits of a time value, is confidence level. Next question. A bias in the variance introduced in the sampling design by selecting the subjects whose results are not independent from each other. So what is this called? A, sample size, B, precision, C, confidence level, or D, design effect. The answer is D, design effect. Design effect is the bias in the variance introduced in the sampling design by selecting the subjects whose results are not independent from each other. So this is the design effect. I told design effect is equal to 1 or no design effect. Where do you use? For simple random sampling. Design effect if it is more than 1. Where? Cluster sampling. Okay, cluster sampling. Chalo. Then next question. What you need to calculate sample size for analytical studies? Options are A, magnitude of the expected outcome, B, desired value for the probabilities of alpha and beta, C, both A and B, or D, none of the above. The answer is very simple. It is C. We require both magnitude of the expected outcome and a desired value for the probabilities of alpha and beta. A measure of how close an estimate is to the true value of a population parameter is called as precision. Just now we have seen. Okay. Next question. The following are the steps in estimating the sample size except. Options are A, adjustment for population size, B, decide on the desired precision of the estimate, C, indicate the expected frequency of factor of interest, or D, identify the minor study variables. The answer is D, identify the minor study variables. Why? Because see, the steps in the estimating the sample size, they have given identify the major study variables, not a minor study variables. So this is the difference over here. Okay, so you have to be perfect with the steps in estimating the sample size. There are around 18 number 1, 2, 3, 4, 5, 6, 7 and 8. Let us see the next question. In the 10% rule, the sample size estimate should be interpreted as providing a maximum estimate of the sample size necessary for the study. Is this a true statement or a false statement? The answer is that it is a false statement, because in the 10% rule, the sample size estimate should be interpreted as providing a minimum estimate. Actually, it's not a maximum estimate of the sample size necessary for the study. Okay. Now, next question. Estimating the sample size identifies major study variable. Is this a true statement or a false statement? Yes, it is a true statement. It identifies major study variables. Next question. All the following are needed to calculate the sample size for analytical studies, except what? Options are A, desired values for the probabilities of alpha and beta, B, magnitude of the expected effect, C, the proportion of the baseline population, or D, single formula depending on the study design, research question and the type of data. So the answer for this question is D, except D, because let us see the options again. Desired values for probabilities of alpha and beta, yes, this is a true statement, correct statement. Magnitude of the expected effect is also correct statement. Proportion of baseline population, yes, you need to know. But a single formula depending on the study design, research question and the type of data. So the single formula is not. You will have different formulas. You will have multiple formulas actually. Okay, multiple formulas depending upon the study design, research question and the type of data. So this is the answer for this question. Sample size estimate should be interpreted as providing nearly maximum estimates of the sample sizes necessary for the study. Is this a true statement or a false statement? Just now we have seen that it is a false statement because it should be minimum. Okay. Now next question. A sample size required for a study will depend on the following except. The options are A. Type of estimate used to measure the outcome. B. Desired precision of the estimate. C. Study design. Or D. Blinding of the participants. Let us see the options again. The sample size required for the study will depend upon the type of estimate used to measure the outcome. Yes. Desired precision of the estimate. Yes. Study design. Yes. Blinding of the participants. No. Okay, because the sample size required for study will not depend upon the blinding of participants. Next question, state whether true or false. The probability of rejecting the null hypothesis when it is true is known as type 2 error. Is it a true or false statement? The answer is that it is a false statement. Okay. Now let us see how we came to this answer. Whenever this type of question comes, type 1 error or type 2 error, I told you that immediately what you are supposed to do, just in the rough paper given to you in the examination, write down this table, type 1 error and this is type 2 error. Okay, you prepare this table immediately in the paper. Type 1 is also called as alpha, type 2 is also called as beta. Then in the first column you put positives and negatives. In the second one you can put what is accepted and what is rejected. Okay, how to remember? I will tell you. See, because this is type 1 error, put as 1. In type 2 error, put as 2. Okay. Now, this one you can easily convert into P. This type 2 error you convert into N. Now, both these things are false positives and false negatives. Okay. False positive you have put and it should be rejected. How will it be rejected? It is truly rejected. It is truly rejected. In the type 1, it is truly rejected. And because in type 1 it is truly rejected, in type 2 it should be falsely accepted. It should be falsely accepted. So this is how you have to remember. Now coming to our question, state whether true or false. The probability of rejecting the null hypothesis when it is true is known as type 2 error. So is this a true statement or a false statement? Okay, the probability of rejecting the null hypothesis, that is, it is over here when it is true is known as type 2 error. Is it true or false? So it should have been type 1 error, but they have asked it as type 2 error. So therefore the answer for this question is false. Okay, but if they could have given it as type 1 error, then the option would have been true. Next question, in a 10% rule, the formula takes into account what? The options they gave are A. Crude association between exposure and disease. B. No confounders are considered. Option number C, that both A and B are correct. Or C or D, both A and B are incorrect. So what is the answer for this question? The answer is C, both A and B are correct. That is, in the 10% rule, the formula takes into account the crude association between exposure and disease and no confounders are considered. Next question, which of the following statements is incorrect about the sample size estimation for a study? The options given are A. Precision is a measure of how close an estimate is to the true value of the population matter. B. A smaller value of absolute precision yields a larger sample size. C. Alpha error is usually fixed at 5% of the biomedical research. Or D. Beta error needs to be specified in a comparative studies. So, what is the answer for this question? The answer is option number B. A smaller value of absolute precision yields a lower sample size is incorrect about the sample size estimation for a study. Okay. Now, next question. An investigator is interested to study the prevalence of hepatitis B among patients attending the STD clinic. For calculation of the sample size of the study, the knowledge about the expected proportion can come from all of the following except. What are the options they gave? A. estimates from a preliminary or pilot study, B, estimates from previous studies, or C, assuming P is equal to 0.5 to yield maximum value of the sample size, or D, assuming the highest possible value for P. So, what is the answer for this question? The answer for this question is D, assuming the highest possible value for P. Now, next question. Following are assumptions for calculating the sample size for a study except. The options are A, the sample is obtained by means of probability sample technique. B, the population is sufficiently large to ignore the finite population corrections. C, the expected proportion P is normally distributed, or D, the sampling is done with the replacement. So the answer for this question is D, the sampling is done with replacement. Once again, the following are the assumptions for calculating the sample size for a study except. We will see the options again. The sample is obtained by means of probability sample technique. Yes. Population is sufficiently large to ignore the finite population correction. Yes. The expected proportion P is normally distributed. Yes. Whereas the sampling is done with the replacement. No. Okay. Now, next question. An investigator is intending to estimate the prevalence of anemia in a selected district. So, the expected prevalence is 28%. The required sample size to estimate the prevalence with the relative precision of 10% and an alpha error of 5 would be what? The options they gave are A, 514, B, 806, C, 1029, or D, 1526. The answer for this question is C, 1029. Now let us see how do we solve this question. What are the values they give? Investigator is intending to estimate the prevalence of anemia in a selected district. So the expected prevalence is 28%. P is equal to 28. They gave the required sample size to estimate the prevalence with the relative precision of 10%. Relative precision of 10%. Relative precision of 10% they gave, and an alpha error of 5. Alpha error, that is type 1 error of 5%. Okay, and they have asked us the required sample size. The required sample size would be what? So let us see the formula. N is equal to Z square into PQ by D square. Z we know 1.96, 1.96 into 1.96 into P. P is 28. What is Q? Q is equal to 100 minus P, which is equal to 100 minus 28, which will come to 72 into 72 by D square. What is D? They gave relative precision of 10%. Okay. So whenever they are giving relative precision, then what will be the value of D? D will be equal to what? This percentage of relative precision into the prevalence by 100 you have to take. So you will get some value of around 2.8. So this D square will be 2.8 into 2.8. So when we calculate, this answer is coming around 987. Do we have in the options? No, we are not having in the options. So what will you do in such scenarios? What can we do is, you will change this 1.96 into approximately 2. Now let us do with this thing by changing from 1.96 to 2. So N is equal to 2 into 2 into 28 into 72 by 2.8 into 2.8. Okay. Now this will, let us calculate. Now this will exactly come into 1029. So here is the answer. So from this question, what have we learned is that when the options are not matching, we got answer of 987. When the options are not matching, what you can do is you can change this 1.96 into approximately 2, and then you recalculate, you will get some value, then probably then that should match with the options given in the answer. Next question. The sample size estimation for a cohort study requires the following except. For a cohort study, he is asking the sample size. Okay. The options are A. Proportion of outcome in exposed group. B. Proportion of outcome in the non-exposed group. C. Desired level of alpha and beta error. Or D. Desired precision of the outcome. So, the sample estimation for a cohort study requires the following except what? Proportion of outcome in the exposed group, yes, this is required. Proportion of outcome in the non-exposed, yes, this is also required. Desired level of alpha and beta error, yes, this is also required. Desired precision of outcome, no, this is not required over here. Let us see the next question. In a study to estimate the mean hemoglobin levels in grams per deciliter among the under 5 children, the expected standard deviation was found to be 2.5 gram per deciliter. If the researcher wants to estimate the mean with a precision of 0.5 gram per deciliter and 95% significance level, then what is the minimum sample size requirement? The options they gave are A 100, B 200, C 300 or D 400. The answer for this question is A 100. Now let us see how do we solve this question. In a study to estimate the mean hemoglobin levels among under 5 children, the expected standard deviation was found to be 2.5 gram per deciliter. Okay. Now, if the researcher wants to estimate the mean with the precision of 0.5 gram per deciliter and 95% significance level, then what is the minimum sample size? So, minimum sample size when a standard deviation is being given, the formula is z square into standard deviation square by t square. Okay, we know the value of z is equal to 1.96. Okay, then they gave standard deviation 2.5 grams and what is d? D is 0.5. So let us substitute the values. Okay, n is equal to 1.96 into 1.96 into 2.5 into 2.5 divided by 0.5 into 0.5. This goes, 5 5s are 25. So this will go, but this will become 25. So it will be almost 2 into 2 into 25. I have taken this as 2, this is 2 because I feel because all the numbers are round numbers. Okay. So this 2 into 2 into 25, 2 2s are 4, 4 into 25, which is equal to 100. So the answer will be 100. This is how you have to solve this question. Next question. Which of the following requires inflation of the sample size during using the design effect? The options are A. Stratified random sampling, B. Cluster sampling, C. Block the randomization in RCT. RCT is C. Block the randomization in RCT, or D. Adjustments for multiple confounders. So the answer for this question is B. B is the answer for this question. So which of the following requires inflation of the sample size using the design effect is? The answer is that the cluster sampling. So with this we come to the end of calculating sample size and power. Thank you.